Okay, these are some notes from 2.6, and this is just finding the domain of the functions. So the first type is really easy because it's just a regular polynomial function. So important things to remember is if it's a regular polynomial function like this one, it's always going to have a domain of all real numbers. So the only thing that causes a domain restriction would be a denominator or a radical, where the x is in the denominator or the radical. So that's an important thing to make note of. I'm going to write that down. There's only a domain restriction if there is an x in a denominator or under a radical. Otherwise, it's always all real numbers. Okay, so A is a simple one. It's all real numbers. We don't even have to worry about A. But let's look at B. It has a domain restriction because it happens to have an x in the denominator. So I actually have more than one. So when I have a situation like this where I'm dealing with a rational function because it's got a fraction, then what I need to do is figure out what would restrict the domain. The reason the domain is restricted is because there's that math rule that you can't ever divide by 0. So what you're going to do is take just the denominator and set it not equal to 0, because that's what cannot happen. The bottom of this cannot go to 0. So I'm going to take x squared minus 2x minus 3, and it cannot be 0. Now if I'll solve this for x, I'll find the things that would make this denominator go to 0, and that's what I can't have. So in order to solve this, I have to factor it. You know, anytime you have an x squared and an x in the same problem, that means it's got to be factored to be solved. So I'm looking for the factors of negative 3 that would combine to give me negative 2, and that would be negative 3 and positive 1. So that means it factors as x minus 3, x plus 1, and that can't equal 0. Now I take each piece, set it not equal to 0, solve each piece, and I end up with x cannot be 3, and x can also not be negative 1. Because either of those two would make this denominator over here go to 0. So the way you have to write this in MATLABS Plus is interval notation. I don't know if you learned much about interval notation last year, but it's pretty easy. What this means is that x can be anything except 3 and negative 1. So it's going to go all the way from negative infinity to positive infinity with just holes at these two spots. So that means it's going to go from negative infinity all the way to negative 1. Neither of those can be included because infinity can't ever be included and it can't equal negative 1. It's going to go from negative 1 to 3 in union with, and then it's going to go from 3 to infinity. On the denominator problems, they'll all be parentheses as your domain restrictions. Now let's look at C. This has a domain restriction also, but for a different reason, because it has an x under the radical. So they gave me the function h of x equals the square root of 3x plus 12. And remember, we can't take the square root of a negative number, or at least you can't get a real number from that and graph it. So what we have to do is take what's under the radical and you're going to set it greater than or equal to 0, meaning that it's either going to equal 0 because you can't take the square root of 0, or it's going to be a positive number. So in this case, I'm going to have 3x plus 12 is greater than or equal to 0. And then solve that for x. So I have 3x is greater than or equal to negative 12. So x has to be greater than or equal to negative 4. So in this case, I go all the way from negative 4 to infinity, because it can be negative 4 as well as any number greater than that. So as I write that in interval notation, it can be negative 4. That means the negative 4 is included. That's what this line under here means. And it goes to infinity. So that's my domain restriction. When you've got a radical, you will usually have at least one bracket. And that's about all for finding the domain of a function.